All right, these notes are on solving absolute value inequalities. So before we go into actually the solving process, I want you to understand the wording and how things make sense. So when I say the absolute value of x, I am saying the distance from x to 0. All right, so we're saying the distance from x to something. That's what absolute value means, is the distance of something. So if I say the absolute value of x equals 3, then I am saying the distance from x to 0 is 3. That's what I mean by that. Now, if we take that idea and we start talking about absolute values, then when I say the absolute value of x is less than 5, then I'm saying the distance from x to 0, that's an x, from x to 0 is less than 5. So if we think about a number line, here's 0. If I want to say the distance from x to 0 is less than 5, then I'm saying that x could be 1, it could be 2, it could be 3, it could be 4, but it could not be 5. It has to be less than that. So if this is 5, x could be all of these values. It could be 4.9, it could be 2, it could be 2.8, it could be any of the values there, but it can't be 5 exactly. But it could also be -1, -2, -3, -4, and any decimal less than -5. All of these would work as well, because -0.7 is still within a distance that is less than 5. -3 is a distance that is less than 5. So if I want to say the absolute value of x is less than 5, then I am saying that the value for x is in between -5 and 5, right? So the way that we remember this is we say that this is a less than, A-N-D. It's between -5 and 5. So we remember that that sign means and. It's in between those numbers. All right. The other situation is we have the absolute value of x is greater than or equal to 4, which would mean the distance from x to 0 is greater than, there's an A there, greater than or equal to, sorry, goodness gracious, equal to 4. Okay, so if I draw my number line, here's 0. The distance of x to 0 could be exactly 4. So 1, 2, 3, 4. That could be the exact distance. Or it can be anything greater than that. So it could be 5, it could be 6, it could be 7, it could be 8. But it can't be any numbers that are less than that. So greater than or equal to 4, a distance of 4, 5, 6, 7. Same thing in the other direction. So it could be a distance of 4 exactly, so x could be -4, but it could also be anything that would create a distance that's greater than that. -5, -6, all of these over here would be greater than that. So we would say if the inequality says the absolute value of x is greater than or equal to 4, our solution would be that x is less than or equal to -4, or x is greater than or equal to +4. Those are all the numbers where the distance between x and 0 would be greater than or equal to 4. So what we remember here is that with this symbol, This is greater. So it is one or the other. Those are the only two things you have to remember with absolute value equations. If you can remember the less than is a sandwich in between those two numbers and the greater is going in the opposite direction, then you can do all absolute value inequalities pretty easily. So let's go ahead and do our first example problem. So we have 4 times the absolute value of 3n plus 6 is greater than or equal to 24. So just like we did when we were solving equations, our first goal is going to be to get the absolute value sign completely by itself on that side. So my first step is going to be to divide by 4. So I have the absolute value of 3n plus 6 is greater than or equal to 6. And now is when I consider the symbol. So my symbol here is a greater. So that means I set up two equations, or two inequalities actually. I'm going to have 3n plus 6 is less than or equal to negative 6, and 3n plus 6 is greater than or equal to 6. All right, so I have one or the other. And then I can go ahead and solve each of these inequalities. So I'll minus 6. So I have 3n is less than or equal to negative 12. I'll divide by 3. N is less than or equal to negative 4. And then I can do the same thing on the other side. I can minus the 6. 3n is greater than or equal to 0. I can divide by 3. N is greater than or equal to 0. And so my solution is, as long as the value for n is less than or equal to negative 4 or greater than or equal to 0, then it would make this inequality true. All right. And then for our second example, we will do 6 plus 7x plus 2 is less than 52. Make that a little easier to see. All right, so to get the absolute value sign alone, I'm going to subtract the 2 over. So I minus 2, and then this symbol is a less than. So I'm going to say negative 50, we're going to be in between negative 50 and positive 50. And then the in between would be 6 plus 7x. So I can go ahead and minus 6. Negative 50 minus 6 is negative 56. 50 minus 6 is 44. And then I'll go ahead and divide by 7 to get the x all alone. So x is in between negative 8 and 44 sevenths, which is why we call it a less than problem.